All right, so this example asks us to find the length of E. And I've copied the triangle down onto my paper, which you need to do every time when we're working with trigonometric questions. It's good to have the diagram in front of you. I notice that it's not a right angle triangle, so I can't use SOHCAHTOA. I can't use any of those ratios, which means that I'm going to, and I can even verify that this isn't a right angle by adding these two together. It gives me 84. So 84, there's no way for the three of them to make a sum of 180 degrees. So I know that that's not going to be a right angle. So I'm going to start off by writing out my formula for sine. The formula is essentially a set of ratios. I know that the ratio of each of the corresponding angles and sides is the same for all three scenarios. So the formula that I have written out for you guys, I'm just going to use these variables. The formula for finding a side length is I take the side length and I make a ratio between the side length E and sine E. That's going to equal the ratio of side length F sine F, and that's going to equal the ratio of side length D over sine D. Probably should have done it in alphabetical order, but that's okay. So I'm going to take a look at what information I have here, because even though this formula has three components, I'm only ever working with two of them. It'll just two ratios. It just depends where I have information. So I'm trying to find E. I have angle E. I also have side D, and I also have angle D. And just remember, when we're labeling our triangle, we always label the sides as lowercase letters and the angles as uppercase letters. And it's always opposite. So opposite of uppercase angle E is lowercase side length E. Opposite uppercase angle D is side length lowercase d. So it's not really labeled on this part, but this would be D. Okay, so because I have and I need information from these two ratios, those are the two that I'm going to use for my formula. I'm going to ignore this one because I don't have information there. I'm not looking for information there, so I really don't need to worry about the ratio of side length E and angle, of side length F and angle F. I'm just going to worry about these two ratios. So that's the formula that I'm going to write out. E over sine E is equal to D over sine D. Next, I'm going to substitute the values that I know and the values that I'm looking for. So I'm looking for angle E. I'm going to keep that a variable. I know that, I'm looking for side length E. I'm going to keep that a variable. I know angle E is 50. Then I know that side length D is 54. And I know that angle D is 34. So that's all the information that I know. I'm trying to get E by itself. I'm trying to isolate it, which means I want to get rid of sine 50 over here. So I'm going to multiply both sides by sine 50 in order to isolate E. No, it's not visible. Okay, and because I've multiplied both sides by sine 50, on the left-hand side, these are going to cancel out. So I'm left with E equals 54 sine 50 over sine 34. And remember, I could have also just put this into the calculator and simplified first. And I'll do it like that in the next example in case you're kind of confused by what I'm doing over here. So sine 54 sine 50 divided by sine 34 gives me 73.97, so I'm going to round to 74.0. And remember, this dot means that I've rounded. Okay, and that's my final answer. That means that side length E is 74 meters. Given triangle DST with angle D being 47 degrees, side length D being 78 centimeters, and side length S being 106 centimeters, find the value of angle S. So we always start by drawing the triangle and labeling the sides. So I'm going to draw an acute triangle that is not a right triangle. And remember, this is just a sketch. It's not to scale. I didn't measure anything. It's just a very rough sketch. Remember that angles are labeled using uppercase letters. So I'm going to label this as D, S, T. And side lengths are labeled with lowercase letters, opposite of the labeled angles. We did this a while back. So angle D is 47 degrees, so I'm going to label it. Side length D is 78 centimeters. Side length S is 106 centimeters. And angle S is what I'm looking for. So I'm going to start off by writing out the formula. So in this case, I'm looking for the angle. So my formula is going to have sine at the top, sine S over S. So the ratio of the angle and the side length equals, I don't know why I started with S, but you can just do it DST in order. Sine T over side length T, and sine of angle D over side length D. Just like I did in the other question, I'm going to highlight where I have information and where I need information. So I have angle D. I have side length S. I have side length D. And I'm looking for angle S, which means I don't need the T, I don't need to worry about. My formula is going to be using these two ratios. You're never going to have an equation that has two equal signs like this. It'll always be some combination of only two of them. This is just showing us that all three are equal. So I'm going to take the 2 and I'm going to write out sine S over S is equal to sine D over D. And I'm going to replace it with what I know. So I'm looking for angle S, so I'm going to keep that a variable. Side length S is 106. I'm looking for angle D. Sorry, I have angle D, and I have side length D. Don't know why I did that. So now I'm trying to find what angle S is, so I need to simplify and rearrange this. This time I'm actually going to put this in my calculator just to show you that you can do it this way also. I can put sine 47 into my calculator to get rid of that sign and just have a decimal. And I'm going to round to 4 decimal places, so 0.7314. Everything else stays the same. I'm trying to isolate S, so I'm going to get rid of this 106 by multiplying both sides by 106. On the left side, they cancel out. And on the right side, I multiply the numerator, 0.7314 times 106, and I get 77.5 over 78. I can simplify this fraction here. $77.5 divided by 78, 4 decimal places, so 0.9939. And then to find the angle, I'm going to do the inverse operation. So S is equal to sine -1, 0.9939. So now I'm going to have to use that inverse key on my calculator. Shift sine, that's how it works on mine. It depends on the calculator. 0.9939. And that gives me, I'm going to round to 1 decimal place or the nearest degree. It's up to you because it doesn't specify, so I'm going to round to 1 decimal place. So 83.7. degrees. So I put the degree symbol. Okay, so that's how it goes. You'll notice that, like I said, this isn't drawn to scale. This angle is almost twice the value of this one, but I didn't draw it to scale, so it doesn't look like that. So that's why it's just a rough sketch.